In this slide, we are going to see albedo effect, polar amplification, and positive feedbacks. These slides are very important from the exam point of view, especially the albedo effect and positive feedbacks. We have read about water feedback process. Now, in this, decline in sea and land ice can amplify warming beyond the release of GHGs. How this happens is ice is more reflective, so this reflection is called a higher albedo, and ice has a higher albedo as compared to darker ocean or land. So the previously ice covered areas absorb more solar radiation, heating up the atmosphere, which in turn melts more ice, exposing more dark areas and reducing the Earth's overall albedo. So this is called albedo effect. This is the primary reason that the Arctic and Antarctic regions are warming faster than other areas of the Earth. Why? Because ice is more reflective and it has got a higher albedo than the darker ocean or land. Then other polar and geographical characteristics like a shallow atmosphere that spreads heat faster, then heat content of open water in the Arctic compound this effect. So this is called polar amplification. This amplification increases or compounds the impact of albedo effect. So this amplifies the average Arctic temperature change to 3 to 4 times than the rest of the northern hemisphere. Now coming to the impacts of this amplification, so the impact is very high. It leads to faster melting of greenhouse ice sheets, Greenland ice sheets because of greenhouse gases, and leading to sea level rise. You might have heard about melting of permafrost releasing GHGs such as methane, and alterations of large scale wind pattern affecting weather across the globe. So coming to the impact, you should bear in mind that the first thing is albedo effect, because ice has got reflective power, and as the ice reduces, so that reflective power gets decreased. As a result of this albedo effect, the warming on the polar areas, warming on the Arctic and Antarctic areas is high. Also, there is a concept called polar amplification, which increases this effect as a result of shallow atmosphere in these areas that spreads heat faster, and the heat content of open water in the Arctic. So this leads to overall increase in temperature. As a result of this, the impacts are many. So the impact can be faster melting of Greenland ice sheets, also leading to sea level rise. Then melting permafrost releases GHGs such as methane, and alterations of large scale wind patterns which may affect weather across the globe. Then water feedback, polar amplification, and any other this kind of self-reinforcing warming phenomena. So there is a term which is known as positive feedback for this kind of self-reinforcing phenomena. Why this is called positive feedback is that it accelerates a change. So in this case, warming. And what happens in a negative feedback? So it slows down the change. This means cooling. So water feedback, polar amplification, albedo effect. So all these are positive feedbacks, and this has got a very important role in shaping up the climate tipping points, which we have seen earlier and will be also seeing in the future slides.